Okay, back to the last little chunk of Chapter 10, Section 9. And again, this one is a challenge. Number one, most students can do it pretty quickly after they rise to the challenge the first time. So yeah, it's like learning to ride that bike. You got to do a lot of things and remember each of the steps, but once you do, it's home free. First thing I want to note is log. When I write log, because I'm more from a mathematical discipline, I mean log base 10. So if everywhere you see log, you think ln, you're good to go. Okay, so if I want a confidence interval for theta, the odds ratio, I know that the standard error can be solved for. The standard error, however, can be solved for in terms of the log of theta. My standard error for the log of theta is the root of the ratio of the number in each of the 1, 2, 3, 4 categories. My upper right, lower left, lower right, upper left. Again, my categories are N11 is the count in the upper left, N12, first row, second column. That's upper right, N21, second row, first column, N22 is second row, second column. The standard error of the log, natural log of theta, hat, our sample odds ratio, is easy to find the chance of. So, steps. First off, find the log of theta. You've just calculated theta hat, find the natural log of it. Second, add and subtract to your estimate, log of theta hat, about 2 standard errors. And then you're going to have a confidence interval for the natural log of theta hat, exponentiate to get a confidence interval for the log of theta. Okay, so subtleties abound. Let's go ahead and just do it. My standard error for my bird ownership problem is easy. And again, referring to the notes that you have, or just going back to the tail end of the last lecture, we've got N11. Well, no, this is not bird ownership. This is the aspirin and heart attacks. 189 heart attacks in the aspirin taking in the placebo group. 10,845 cases, I guess, of no heart attack in the placebo group. 104 heart attacks in the aspirin taking group, and in the aspirin taking group, no heart attack, 10,933. Reciprocate and root. Reciprocate, sum, and root. I get a 0.123. Okay, so my confidence interval for theta hat is going to be the log, natural log of 1.83, which is 0.604. So I'm going to say try on your calculator the natural log of 1.83. You should get 0.604. By the way, the most commonly screwed up question on the exam, this next exam, is students forget that it's a natural log and they use a log base 10. Or when they exponentiate later on, they raise things to the power of 10. Everything's base E in this last section of chapter 9.4. Okay. So my confidence interval for the log of theta is, well, my log of theta hat plus or minus 2 standard errors, 0.604. That's my estimate. Plus or minus 1.96 times that standard error, 0.123. 0.604 plus or minus 0.241. And this is the first time when I would say you cannot or you should not convert things into the, just leave it as the plus or minus. You need to go with the 2 endpoints. So literally our 2 endpoints are 0.363, 604 minus 241, 0.363, and 604 plus 241 gives me 0.845. And exponentiating e to the 0.363 and e to the power 8.45 gives me 1.44 to 2.33. So theta hat is 95% sure to be in the 1.44 to 2.33 range. Now, remember, rare outcomes. A heart attack is a rare outcome, so theta hat is approximately equal to the relative risk. So I'm going to give the increased risk interpretation. Again, the increased risk, IR, is the relative risk minus 1 times then 100%. My 1.44, okay, theta endpoint is a relative risk of 1.44, or the increased risk is 44% at the bottom end. 2.33 as a odds ratio. The upper end of my odds ratio confidence interval happens to be with a relative risk of 2.33 or an increased risk of 133%. So the folks who are taking aspirin or not taking aspirin are 44 to 133% more likely to have a heart attack. So if you are at least 50, but possibly 150% less likely to have a heart attack by taking aspirin, would you do it? I'm thinking I would. So with that in mind, there are opportunities to practice in the homework. Again, the 1, 2, 3, 4 steps, which are fairly important, are to 1, find the log, natural log of theta hat. 2, find the standard error for the natural log of theta hat. 3, calculate your range expressed as the endpoints. 4, exponentiate each the lower and upper endpoint. And then finally, if possible, re-express that as an increased risk. Again, the lower and the upper values, subtract 1 from them and multiply by 100%, and that gives you a confidence interval. In our case, I'm 95% sure that if you were taking the placebo instead of taking aspirin, you're 44 to 133% more likely to have a heart attack. The increase in the risk of a heart attack is 44% higher to 133% higher. Okay, so that's a bit of subtlety. So I'd say make sure you can tackle every problem in chapter 10, section 9 before you do these confidence interval problems. Make sure you can get them all right and then do the confidence interval. With that in mind, enjoy the rest of your day. We will see you soon. Bye.